We've talked about how pesticides pose concerns for you and others. This presentation will help you become familiar with concerns about having pesticides released into the environment. You need to understand factors that contribute to pesticide drift and runoff. You need to be able to identify areas that are sensitive to pesticide applications, and you'll need to understand how to minimize the impacts from your pesticide application. It's important to realize that when EPA registers a pesticide, the products are tested for the risks they pose to the environment. When EPA reviews the data, they make certain that appropriate concerns and protections are detailed in the product label's environmental hazard section. Manufacturers spend a significant amount of time and money investigating how their product interacts and affects the environment. Prior to registration, product characteristics are studied in the laboratory to predict environmental concerns and to make sure protective language is included on the product label. The manufacturer investigates how products move in the environment and how readily they break down. Other studies measure effects on non-target plants, birds, fish, invertebrates, and other animals. For products that pose a significant environmental concern, EPA restricts their use so only qualified individuals have access to them. When we consider the impacts of pesticides on the environment, we have to look at everything around us: the air, soil, water, plants, animals, people, outside buildings, and even inside treated buildings. There are usually some very sensitive areas that must be considered, whether they are people, beneficial organisms, water, or listed threatened or endangered species. We talked earlier about the concern the public has for pesticides in the environment, and EPA requires testing to assure pesticides can be used with no unreasonable impacts to the environment. This module is to help you understand the basic interactions of pesticides in the environment. You need to understand some chemical characteristics and how pesticides break down following an application. Once a pesticide is applied, you need to understand some of the dynamics of its movement in air, water, and soil. Lastly, we'll discuss special assessment considerations to protect sensitive sites, pollinators, aquatic organisms, and other animals. Let's start by looking at 4 different pesticide characteristics: solubility in water, adsorption onto soil particles, persistence in the environment, and volatility into gases. Solubility. Does it dissolve in water? A pesticide that readily dissolves in water is said to be water-soluble. Water-soluble pesticides are more likely to move with water. Water-soluble products can easily run off with surface waters that don't penetrate into the soil. For water that moves through the soil, water-soluble pesticides are carried downward into the soil profile. Once in the soil, the question becomes, where does the water go and how fast does it take for the pesticide to degrade? Pesticides that are not water-soluble don't move readily with surface or subsurface waters. The adsorption characteristic is important to the fate of pesticides. Adsorption, that is adsorption, is a physical binding of the chemical to the outside of soil particles and organic matter. Add means to add onto. Adsorption is different from absorption. Absorption sucks material into something like a sponge sucking in water. Adsorption is binding to the outside, like lint stuck on your shirt. Pesticides that are oil-soluble or oil-loving tend to adsorb or bind to soil particles. Soil type is a key factor as to how much pesticide is held by the soil particles. Clay and organic soils have many binding sites and adsorb a lot of pesticide. If pesticide is adsorbed or bound to the soil, it doesn't move freely with the soil water, and water contamination concerns are greatly reduced. Persistence is another important characteristic when assessing impacts on the environment. Persistence is the measure of how long a pesticide remains active before it degrades. If you want long-term pest control, seek out a pesticide that's persistent and doesn't readily degrade. But realize persistent pesticides don't break down for some time, and they can harm sensitive plants or animals. Persistent pesticides also pose concerns for illegal residues on rotational crops that can pick up the chemical because the product was not labeled for that rotational site and no tolerance was set. Volatility is a characteristic of vapor pressure. Depending on the temperature and humidity, and in some situations wind, a chemical changes from a liquid or solid state into a gas or vapor. As vapor, it can move off target with the airflow. Increases in temperature and wind increase the potential for volatility. Also, lower humidity levels increase the potential for volatility. Fumigants are effective in their vapor state. The vapor is the form that moves through soil particles during a soil fumigation or through cracks and crevices in structures or grain kernels in stored grain. However, under certain field conditions, some herbicides volatilize and move off target, possibly reaching susceptible plants. Because the manufacturers have screened their products for this characteristic, they put volatility warning statements on labels. So look for cutoff temperatures listed for certain herbicides. This is also why soil fumigant labels require immediate incorporation and soil sealing. Understanding how readily a pesticide degrades and how it degrades are also important. Microbial degradation is a primary means for destroying pesticides in the soil. There are a number of microorganisms like species of bacteria and fungi that use the pesticide as food. As the microbes feed on pesticides, they break them down. Soil conditions that favor microorganism reproduction increase the degradation process. So, soils that are warm, have adequate moisture, and a favorable pH provide the right conditions for rapid pesticide degradation. Also, soils with a good mix of oxygen, sufficient fertility, and with pesticide adsorbed onto the soil have increased degradation. Non-living processes also cause degradation. Simple chemical reactions occur in the soil. Something as simple as a mixing of water and the chemical can result in hydrolysis that causes chemicals to break down. Again, soil properties and conditions affect which chemical reactions take place and how quickly. The sun can cause chemical degradation. You've probably experienced the effect of photodegradation, where the sun is responsible for chemical breakdown, like when your nylon tarp wears out. Sunshine is very effective in breaking down chemicals. Remember, this is why you hang your laundered pesticide application clothing out to dry in the sun. Some chemicals break down so quickly they must be immediately incorporated into the soil. Others can only be used indoors where the sun doesn't shine. To understand how pesticides might impact the environment, we have to look at how they move from the application site to other sensitive areas. We'll look at each of these pathways in detail. The major pathways are through air as vapors, dust or spray droplets, through surface water or soil water, or through plant or animal tissues removed from the application area. Spray drift is the movement of spray droplets in the air. The spray droplets are carried in the air beyond the application site. A concentrated dose of droplets that moves off target can cause damage or leave illegal residues. To minimize off-target spray drift, labels state specific precautions. The label may require a mandatory no spray buffer between the application site and a sensitive area. The label may stipulate exactly what size droplet classification can be used during the application. Wind speed conditions, both very low winds and high winds, may restrict applications. The label may require you apply a certain volume of spray. Aerial application may be restricted on some labels. Labels may have specific precautions listed for sensitive crops or sites, like schools and daycares. Let's review the 4 factors that contribute to drift. The applicator's attitude is very important. The applicator assesses the site and concern level for drift. The applicator selects what application method and chemical formulation is most appropriate and sets up the equipment to either produce larger or smaller droplets. The applicator monitors the weather and makes a decision whether to spray or not. It appears from the picture here that the applicator had significant drift from his turf weed control application. He made a very bad set of decisions. The applicator must conduct a site assessment prior to any application. It's necessary to identify any sensitive areas or areas of concern. Is there a need for a no-spray buffer to ensure that there's no contamination of certain sensitive sites? The applicator must assess the weather conditions, such as the possibility of stable air conditions. What's the wind direction and speed? And the temperature? You must understand these factors in order to manage the application to minimize off-target movement. Understanding the concerns for drift, the applicator selects the appropriate application equipment and sets it up properly. Ultimately, after all the planning and preparation, the applicator must make the decision to spray or not to spray. The basic principle to understanding drift is understanding droplet size. Big droplets don't drift. Small droplets tend to stay in the air for a while prior to the effects of gravity causing them to settle to the surface. You can manage drift by managing the droplet size. Consider making larger droplets. The equipment can be set up to reduce the potential for off-target movement by recognizing the impact of droplet sizes and boom height. Nozzle size and pressure determine droplet size. When managing for drift, use larger droplets, like medium or coarse-sized droplets. Select the appropriate nozzle size and pressure to deliver that size class. Droplet size class may be stated on the label. The nozzle orifice is the size of the hole in the nozzle. As you increase the nozzle orifice size, your droplets become larger. As you decrease nozzle orifice size, droplet sizes get smaller. As you increase pressure, droplet sizes decrease. So, to manage for drift, you typically use nozzles with larger orifices and at lower pressures. Boom height directly affects how long sprayed droplets stay airborne. Drift potential is reduced when the boom is closer to the target. Because some labels actually state what size droplet class you must use, nozzle manufacturers have charts that detail droplet sizes based on the nozzle orifice and pressures. Make sure you comply with label requirements. Here, the yellow M indicated medium-sized droplets and blue indicates coarse-sized droplets. The chart shows what nozzle type, size, and corresponding pressure gives what droplet class. Viscosity of the tank mix is another factor that may be considered. With thicker spray mixes, the droplets remain larger. That's the benefit of invert emulsion formulations. Invert emulsions are oil-based and don't readily evaporate. Water-based formulations are affected more by temperature and humidity. There are some drift reduction adjuvants or deposition aids on the market that increase the number of larger droplets. You cannot change the weather, but you must be able to read the weather. Wind is a key weather condition that must be measured. Wind direction is the most important factor. You must know what is downwind. You're going to have some off-target movement with any spray application, so you'd better know what's downwind. You have to assess what precautions to take to protect that downwind area when necessary. Wind speed affects whether you can determine wind direction and also affects how far the driftable droplets move. When applying in winds that are below 3 miles per hour, you can't really determine the wind direction without using smoke or some other device, and the direction can easily fluctuate under low wind conditions. Droplets still move, but you don't know where, and you can't take the necessary precautions. Applying in winds between 3 and 7 miles per hour allows you to easily measure wind direction, and you're able to assess what's downwind. Temperature and humidity affect the life of the droplet. As temperatures increase, droplets evaporate into smaller droplets. As humidity decreases, evaporation also increases. So you'd expect more driftable droplets under conditions of high temperatures and low humidity. Applying during a temperature inversion can result in very damaging, very long distance drift. Under an inversion condition, the air is very stable and it moves with any minor airflow. Inversions occur when warm air, that is light, rises upward into the atmosphere and the cool air, that is heavy, settles near the ground. With these conditions of warm air above cool air, there is no mixing of air, so the air is stable. With stable air, the droplets that drift are not dispersed, but stay in a concentrated mass and move with any subtle airflow. You can even have winds during inversion conditions. Under normal or unstable air conditions, air is continually mixing. In this graphic, you can see the dust actually become diluted as it moves away from other particles. Spray droplets do the same thing. They move apart from each other and become less concentrated. This illustration shows that smoke is a good indicator of air stability or inversions. You can easily visualize the concentrated mass of smoke particles moving here. Can you imagine if these were spray droplets? How far could they go? Miles. Temperature inversions can and do occur at any time, especially in hilly or mountainous terrain. They typically form at dusk as the sun sets and the cool air settles. Inversions often continue through the night and don't break until the sun is up and starts to warm the ground. Once the ground warms, the cool and warm air start to mix. The major problem with inversions is that applicators perceive little wind or air movement and assume this is a good time to spray. In actuality, it's the worst time. If an application is made just as an inversion sets in, let's say at 4 p.m., and it doesn't break until 9 a.m., that allows for droplets to move with any airflow for 17 hours. With a half-mile-an-hour wind, droplets could move in a concentrated mass for 8.5 miles. Now let's consider vapor drift. Vapor drift occurs when a pesticide changes to a gas form and moves off target. This occurs with several herbicides when temperatures warm up during the day. Check the herbicide label for precautions about vapor drift and follow any guidelines that stipulate cutoff temperatures. Some labels state, "Do not apply if temperatures will exceed 85 degrees during the day." If you have concerns with volatility, select low volatile formulations. Certain pesticides remain active on the soil after application. If the treated soil or road dust moves off target, it can contain active pesticide. Precautions are listed on the product label if particle drift is a concern. One method to manage for particle or dust drift is to immediately incorporate the pesticide into the soil with tillage, rainfall, or irrigation. In this picture, a pesticide was applied along the road shoulder and was not incorporated. Wind blew the soil into the adjacent field and caused damage. Pesticides may get into water from either an identifiable source or from a general contamination. We use the term point source for pollution that occurs from an identifiable source, and we use the term non-point source if the source can't be easily identified. Point source pollution occurs from an identifiable source, such as a spill or a leak. Contaminated water may enter the water system through the sewer or from contaminated mixed load and wash sites. This can result in contaminated surface or groundwater. A direct contamination of water sources can result if back siphoning occurs when filling a sprayer or when check valves aren't installed in a chemigation system. Improper handling and disposal can result in point source pollution, so be very careful with your handling procedures. Non-point source pollution can result from a wide variety of sources and not a single identifiable source. Surface water contamination can result from any number of sources, like contaminated runoff. The general contamination of water is usually attributed to non-point pollution. Runoff is a key mechanism for moving pesticides into surface waters. By making a pesticide application that's followed shortly by a rain event or irrigation event, the soil becomes saturated. Water then runs off the surface instead of percolating into the soil. As the water runs off, it carries water-soluble pesticides that are at the surface with it. This results in contaminated ditches, streams, rivers, ponds, and lakes. The use of the contaminated water source for drinking, livestock watering, irrigation, fish habitat, or any number of other uses is impacted. The factors that contribute to whether a runoff event occurs include the grade or slope of the area, as well as soil texture and the amount of vegetation. Soil that's saturated can't take in the water, so it runs off. The amount and timing of irrigation or rainfall is critical. The pesticide characteristics, especially water solubility, also play a role. When contaminated water moves in the soil, not over it, we call this leaching. Again, pesticides that are water soluble tend to leach through the soil. The contaminated soil water may move horizontally to nearby roots, or it may move vertically through the soil profile down to the groundwater. Pesticides that tend to leach are those that are highly water soluble, don't readily absorb onto soil particles, and don't degrade quickly. How vulnerable a site is to leaching depends on several factors. The geology of the site, or how permeable the soil is, affects the soil's leaching potential. Soil texture plays a key role in how fast water moves and how much pesticide is held by the soil. Sandy soil has very fast percolation and few adsorption sites. On the other hand, it takes water a long time to move through clay and organic matter soils, and these soils have thousands of adsorption sites to hold some chemicals. The depth of the groundwater is also key. If the groundwater is shallow, your concern about leaching should be great. If the depth is quite deep, the water has to move a very long distance to reach the groundwater, and the product will most likely have been degraded. For leaching to occur, you must have water. So saturated soils, heavy rainfall, and over-irrigation contributes to the concern. We have just covered some basic chemical characteristics, degradation principles, and ways pesticides move in the environment. With that background, let's look at some special environmental considerations. We'll look at each of these bulleted items separately: groundwater, sensitive sites, and non-target organisms. Because so many people in the United States rely on groundwater as their drinking water, it's imperative that pesticide applicators use great care to protect the health of our groundwater. Once contaminated, groundwater is nearly impossible to clean up. Let's review a few important terms. Surface waters are those waters present at the Earth's surface, lakes, rivers, and oceans. Fresh surface water is also a major source of drinking water. Recharge is the water that seeps through the soil from rain, irrigation, or melting snow. The water table is the uppermost saturated zone of soil. Usually wells are put in deeper than the water table. An aquifer is a layer of sand, gravel, or limestone that is fully saturated with water. Product selection is a key consideration in preventing groundwater contamination. If you have a site that's vulnerable for leaching, make sure you select a product that doesn't pose a concern for leaching. The label clearly states any concern in the environmental hazards section. If you're applying to a site for which there is little or no concern for leaching, product selection is not as critical. Using other management approaches might be an appropriate decision to minimize the concern for leaching. Again, consider the geology of your site and depth of the water table. Know of other concerns like sinkholes that indicate water level concerns. Consider the soil characteristics if you're using a pesticide that can leach. If your application site is vulnerable to groundwater contamination, be very careful about which product you select. After selecting a product, make sure you follow the use directions and adhere to the rate of application stated on the label. Over-application can overload the soil and result in water contamination. Prior to product selection, conduct a vulnerability assessment of your application site. Does it have sandy soils or sinkholes? Water moves easily and quickly through sandy soils. Are there any wells, streams, or ponds nearby? How shallow is the groundwater? Make sure you handle pesticides and their wastes to prevent soil contamination. Calibrate to make sure you're not over-applying or overloading the soil. Check for leaks in your application equipment. Measure products carefully so you don't over-apply. Think about where you mix, load, and rinse your application equipment. Make sure that contaminated materials cannot enter drains or waterways. If you don't have an impermeable mix-load pad, don't mix, load, and rinse your equipment at the same location each time. Protect water sources from back siphoning. The easiest way to prevent back siphoning is to create a gap between the level in your tank and the hose. Liquids can't jump the gap, so they can't enter your water source. However, things happen and sometimes the hose gets into the spray mix. So the best method to prevent water contamination is to install a back siphon or check valve at the water source to prevent the movement of pesticide spray mix into the water source. You really can't be too careful when it comes to protecting groundwater. Avoid spills and clean them up immediately if they occur. Decontaminate the area. Handle your waste properly. For pesticide containers, immediately triple or pressure rinse them and use the container rinse water in the batch of spray you're making up. Be careful where you locate your storage facility. Make sure it is away from water sources. Watch the weather. Rain or irrigation are the factors that provide the water that moves the pesticide. Hold off your application until after a heavy rain. Don't irrigate right after an application and don't overwater to the point of runoff. Consider the possibility of sensitive sites that may be adjacent or near your application site. Protect people and take special care when applying near children or places where there might be elderly or ill people. Consider locations that are inhabited by sensitive plants, animals, fish, or insects. Be careful when applying near yards and people's gardens. Don't contaminate adjacent crops. When making applications indoors, consider exposures to people and animals. Ventilation may be required. Know if there are listed endangered or threatened species in the vicinity of the application site. Pesticides can directly and indirectly impact non-target organisms like plants, bees, and other pollinators, beneficial insects, fish, wildlife, and humans. When applying herbicides, be very careful you don't affect nearby plants. Damage symptoms may be obvious, and it may be fairly easy to determine the source. However, some plant pathogens cause damage symptoms similar to herbicide damage. Check the label for any precautions about phytotoxicity or off-target drift. Be aware of blooms in the area, whether it's the crop or weeds that are blooming, or flowers in an ornamental bed. Broad-spectrum insecticides can kill individual bees or be taken back by foraging bees and fed to the entire colony. If you have blooms, either mow them prior to making the application or don't make the application. Be careful with spray drift that can reach blooming plants. Bees tend to be lazy and don't forage early in the morning or late in the afternoon, so you may be able to time your application when they're not present. Some insecticides aren't harmful to bees. Also, some formulations are low hazard. Microencapsulated insecticide formulations, dusts, and wettable powders can be very harmful, since bees can capture these formulations in their leg hairs when they collect pollen. Read the label for notes on bee toxicity. If possible, spot treat instead of doing a broadcast application. If you have hives in the vicinity, communicate with the beekeeper. Not all insects are pests. You need to be able to recognize the beneficial insects that are present in your agricultural fields or in your landscapes. These beneficials play a role in managing pest populations. The top image shown here is a parasitic wasp laying its egg into the body cavity of a caterpillar. The bottom image is the larval stage of a ladybird beetle. Be careful what insecticide you select and how you apply it. Fish can be directly affected when exposed to insecticides and algicides. Herbicides can alter plant communities and oxygen levels, which can harm fish populations. If you have a spill, protect runoff into waterways. Be careful that your applications don't drift into water systems. Dispose of your waste properly. Livestock, birds, and wildlife can also be impacted by pesticide applications. Birds and mammals may eat treated seed, baits, or pesticide granules. Follow directions regarding the placement of some of these products to ensure that non-targets don't get access to them. An application can directly expose and impact animals. Consuming contaminated food or water can affect animals. Even animals that feed on contaminated prey may be poisoned. We call this secondary poisoning. Store your products carefully. The Federal Endangered Species Act was passed by the U.S. Congress to protect endangered and threatened species and their habitat. Make sure that any pesticide application you make does not in any way harm the habitat or the protected species. Some product labels require that applicators consult a county bulletin that contains additional precautionary measures and restrictions, and these precautions must be followed. To protect the environment from undue exposure, make sure you understand how pesticides move in water and air. Understand the factors that contribute to spray drift and what measures you need to take to minimize off-target spray drift. Manage your storage, handling, and application practices to protect both surface and groundwater. Assess the weather and soil factors to make good decisions. Consider sensitive sites prior to selecting a product and making an application. Products have label warnings to protect the environment from harm. Follow the labeled directions. And don't forget to protect yourself, your family, your neighbors, and your pets. Be responsible when you plan and make your applications. Question 1. Which of the following techniques would reduce spray drift? 1. Increasing nozzle size. 2. Decreasing pressure. 3. Decreasing distance between the boom and the target site. 4. Decreasing the viscosity of the spray solution. Select the correct answer. A is 1 only. B, 1 and 2 only. C, 1, 2, and 3 only. Or D, 1, 2, 3, and 4. The correct answer is C, 1, 2, and 3 only. Question 2. You need to control aphids in a blooming alfalfa field, and the product lists a bee toxicity hazard. What application precaution can you make to protect bees? A. Applied mid-morning when temperatures are warming. B. Apply a dust formulation instead of an emulsifiable concentrate. C. Use a systemic granule formulation. D. Move hives that are next to the field to 300 yards away. The correct answer is C. Systemics move into the plant and granules are not picked up by the foraging bees. Question 3. Surface and groundwater contamination occur most frequently with water-soluble pesticides. Which of the following events would be a concern with a water-soluble pesticide? 1. A rain event following an application. 2. Applying to dry clay soils with a well 150 feet away. 3. Pouring container rinse water on the ground. 4. Using an air gap instead of a check valve when filling a spray tank. Select the correct answer. A. 1 and 2 only. B. 1 and 3 only. C. 2 and 3 only. D. 3 and 4 only. The correct answer is B, 1 and 3 only. This presentation was authored by Carol Ramsey, Carrie Foss, Becky Hines, and Brett Johnson of Washington State University Urban IPM and Pesticide Safety Education. In addition to sources noted on the image, graphics were provided by the following sources: Nevada Department of Agriculture, University of Missouri-Lincoln, Virginia Tech, Washington Department of Agriculture, and Washington State University. The presentation material was reviewed by Ed Crow, Maryland Department of Agriculture, Jeannie Kasai, United States EPA, Beth Long, University of Tennessee, and Susan Whitney King, University of Delaware. Narration was provided by Carrie Foss, Washington State University Urban IPM and Pesticide Safety Education Program.